I've still got some of these filaments left. This is how they come, by the way, the LED filaments. They come when you buy them in a modest quantity on the strip. And it's interesting to note that there's large holes at one side of the strip, the negative side, and there's small holes at the positive. But they weren't actually marked with polarity, which wasn't terribly helpful. Fortunately, there's the slight light colour at one end to identify the positive inside the insulator. So I was thinking, what can I do with these? And I had a spare base that I'd taken off a dead compact fluorescent lamp, and I was thinking I could put a glass test tube into that. So I measured it, got some test tubes, and yep, that's pretty good fit in there. And that kind of suggests that I could make a lamp that looks like this, with filament zigzagging down like that. So that's what I'm going to do with the electronics at the bottom inside the lamp. So the circuit diagram for that is going to be fairly simple. The temptation, I have to say, the temptation was initially to go, say, live, neutral. It's not necessarily live, neutral. Single diode to the capacitor, which is a bit tacky, and the inrush current limiting resistor, 100 ohm, and then just 122k resistor, and then the four sections of filament, and that's the simplest that you could possibly do it. That's about right, isn't it? Yes, I wasn't sure if there's going to be much shimmer or flicker with that. I don't think there would be. However, it's tacky, so I'm not going to do it. I'm going to do it proper style, and I'm going to have live and neutral, just say mains, because it doesn't really, it depends which way you put the bayonet cap lamp holder in, which is live and which is neutral, but I'll just label one as live and neutral. So I'm actually going to use two 100 ohm inrush limiting resistors, purely because it's nice and symmetrical and they can be the base of the circuitry. Then it's going to have the bridge rectifier, which is going to be based on 4 discrete diodes, 1N4007s, AC in, there we go. The output is going to have a capacitor. This 400 volt 4.7 megafarad capacitor that came in a packet from a Chinese supplier, and one of them was covered in the sort of fluff that you might expect from a turbo electronic incident. Not sure about them, but we'll find out. It may explode when you turn the power on, but not to worry. Then I'm going to use two 10k resistors. I don't need to use two 10k resistors, but again, it's nice and symmetrical. That will then feed the filaments, and I may actually just add a 1 megohm discharge resistor across here, because it can also be used to separate the base of the filaments, all for symmetry and structure. So I'll just mark that as LED filaments. The maths are such that each of these filaments is about 70 volts, so that's going to be 280 volts. I'm going to get roughly 350 volts across the capacitor. So the difference is going to be about, actually, let's see now, what am I going to get here? 350 minus 280 is about 70 volts. 70 volts divided by 20k, 70 divided by 20k equals 3.5 milliamps, and that's times 70 volts equals roughly quarter a watt, but it's divided between two resistors, so that's pretty good actually. That looks as though it's going to be quite nice. That's going to be fairly bright. So that's the circuit. Let's make it. So here's all the diodes, and the first thing I'm going to do, I'm going to make the discrete rectifier by just about 5 millimeters from the end, which is just under 1/4 of an inch. I'm just going to fold these across. And this is the positive end of the rectifier. Snip, snip, snips. I'll use these ones. Oh, I've suddenly remembered what the other ones are. I should really look things out before starting. If you notice the fingers are looking a bit sort of rusty at the end, it's because it is in fact rust, because I was fixing my heating as I run. So I'm just going to tin those and join them. making the positive end of the rectifier. I'm trying to keep in mind that the size of the tube is an issue for how wide I can make the components in it. Oh, I'm really, really messing this up. Well, this is a good start. It'll get even messier when I try soldering this onto the onto the capacitor, because this is the end that's going to have the rectifier on it. Right, that'll do at the moment. It's a bit rough, but that'll do. And I'll make up the negative end in the same style. Correct snips this time. I think I'll cheat and enlist a little helping hand here. So that's the negative end of the rectifier. And while I'm at it, since I've made that look so much neater on the other side, I'm just going to redo the other side. That should do it. And the other end, I'm going to fold these leads at right angles to the other orientation. And these will be the AC ends of the rectifier. So cutting the leads to roughly the same length. I should try and remember and try and keep this in shot. Tin that and this one, and I shall join that like that. And likewise the other side. I'll just flow the solder right onto this. Lovely. So that's the rectifier, and now the positive end of this rectifier is going on to the positive lead of the capacitor, which is probably a good thing really. Be a bit messy if I put it in the other one. Now how do I want to do this? Tricky. I think I want to bend the capacitor leads out carefully without putting undue strain on them. Make sure I get this the right way around. That looks pretty good. Get it roughly central. Everything should more or less hold itself in place now. Oh, actually, you know, I am putting this the wrong way around. That would have been absolutely delightful. That would have been a guaranteed explosion when I powered that up. That looks pretty good. Let's see if I can solder this without the leads all popping apart again. Looks pretty good. And likewise the other side. Okay, that looks excellent. And I'm going to part these away. I was squeezing them in towards capacitor just for the ease of assembly, but I'm going to have to part them away now because I'm about to add the two 100 ohm resistors. That should more or less sit on its own now, so I need two 100 ohm resistors. Make sure I don't mix these values up here. Now I want these to go right down into the connections down here, but still come up enough that it's going to look quite good, because I quite like the idea of all the circuitry sticking up in here and being visible. So I shall pretty much leave these almost full length. I'll match them both to the same size. And tin the ends. And add them to the input of the rectifier. So that's one. Looking good. And that's two. Going right here. Whoop. That looks alright. Okay, so that's the bulk, that's our DC supply now. These not only act as inrush limiting resistors. If the worst happens, if something goes horribly wrong, these should they should fail. Now I need to add, on the end of these, the two 10K resistors. So I shall solder them onto the ends of the capacitors leads. Hopefully this is all going to stay put together. When you're soldering sort of skeletal electronics like this, it can sometimes get a wee bit springy. So I'm just going to tin those. Hopefully everything will stay put. Looks pretty good so far. And I'll be keeping the resistors fairly short. Maybe about just over 1/4 of an inch. And these are the 10K resistors. These are the ones that will limit the current through the LEDs from the smooth DC supply. Oh, this is going to be a bit delicate. There we go. I'd also want to make sure I don't use too much space, because I want to leave plenty of room for the filaments, although I think the test tube's got plenty of length for that. So on goes the other resistor. Try and keep it the exact same position as the other one, just so it looks roughly sort of symmetrical. I did wonder why the Chinese lamp manufacturers don't just put the electronics inside, and I'm not really sure why, other than the fact that if I put this in a sealed tube and then the electrolytic capacitor vents explosively, it could break the lamp. Maybe that's why they're trying to keep the electronics out of it. Okay, right, let's make the filament now. So I've marked these with a red dot at the positive end, but I also marked the front because I want all the fronts to be in the same direction, because with these LED filaments, one side tends to be a lot brighter and orangier than the other. So I'm going to cut these now, and I'm going to leave as much room as I could possibly can. Then I'm going to join them in pairs. Being very careful with the soldering so I don't actually damage the LEDs inside them. Because these are the last ones, intact ones I've got left that I've not messed about with. And I want them all to match. So I'm going to tack these together. Okay, that's one pair. Now this will be coming, that'll be going up to the top positive end, then the positive end at the top will be coming down, so I'll put that there. And we'll join these. Now, this is where I wonder if I've got enough room to actually join these and still have, they're actually a wee bit close to, I think that's going to work. I'll try it. I'll try soldering them directly, but if it's not going to work, I don't want to put too much pressure on them. So it's where they actually, the virtual filament comes to a point. I don't want to put too much stress on them for when I'm bending them in case it actually damages the ends of these LED strips. Right. So I'll put that like that. And I want the positive to be pointing up the way, and I want to get that as tightly as possible. Oh, that's not bad. And now I want to actually bend one this way very carefully. I'm going to use pliers to do this so I don't put strain on the LEDs themselves. And then I want to bend one the other way to give it a sort of more three-dimensional look. Like that. Ooh, without the filaments getting too bent. Looks pretty good. Let's see how that's going to look in the test tube. Yeah, that should fit in okay. Excelente. Now, how much space am I going to have here? Because that's going to come down to about there. Oh, there's plenty of room. Yep, okay. So I shall now cut these 10k resistors, which aren't perfectly parallel, but that's okay. It is homemade after all. And I still have to decide, do I want a 10k discharge resistor? I think I do. It's not a 10k, a 1 megohm discharge resistor. It's a safer thing to do. It also means that in the event of anything going horribly wrong and the LEDs going open circuit, the capacitor is going to always have a load to keep it just trickling away current so it doesn't accumulate voltage spikes and the voltage on it doesn't go too high. So I'm just going to bend those in a wee bit, solder the resistor directly across them. Whoops. Same with the other end of it. Oh, that didn't actually solder. That's a bit unprofessional of me. I shall fold that up a bit. That's better. Okay. And I think I'll crop that there and then fold the 1 megohm resistor leads up, and they can be the ones that actually connect to the LEDs. So this is a positive, so it will connect to this. So I'll just tin the bottom LEDs, and in fact I might just clamp that in with the helping hands. Ooh, slightly over generous blob of solder there. And a wee touch of solder on here. So there's the positive side, and I'm going to connect that to the positive side of the LED string. And the other side to the negative side of the LED string. And at this point, I suppose it'd be a good idea to test this. And a good way to test that might be, if I can actually get them into it, is to use, that's a bit far in, so I'll use my slightly dubious tester. So I'm just going to double check here that diodes from each side, one diode from each going to positive, one diode from each going to negative, current limiting resistors. So yep, I shall stick that in here and power it up, and hopefully it won't go bang. It depends on how good those capacitors are. Testing. Oh, that's pretty good. Pretty good indeed. Yeah, okay. Should just bridge out that, because even with a 1 mega ohm resistor, it could still hold a charge for a while. And now I'll take my base here and desolder the two leads that are in it already. And ping the solder out scientifically. Looks pretty good. Try not to make too much of a mess so it doesn't short something out when I put it into the lamp holder. That should do. And I shall put these two resistors into this, bearing in mind they're going to be covered in a glass tube, so I don't have to worry too much about them touching the side of the housing. You'd obviously, in America, you'd have to, or wherever you use Edison's screw, which is just about every other country, you'd have to use a different arrangement to this. So I'm just going to mount these up at a good height. I'm also going to check how this is going to look inside a test tube. It's going to look okay, I think. So I shall mount those resistors at about that height. Oh, this is where it all gets a wee bit tricky. Error. Okay, I think I'm going to mount it in as far as comfortably possible. I could do with a slightly thicker bit of solder here, but I've only got the thin solder to hand, so I'll use the thin solder. And flood that on. Then once that's hardened, takes a wee while to harden, I shall get the other one just roughly central. I may even just apply the tube across that just to act as a sort of guide. And then flood the other one with solder. And once I've flooded them like that, I've actually put on a lot more because I like these to be quite chunky pads. The bayonet cap lamp holders have quite a huge tolerance of the depth of the solder connection end. And the thicker the better, because it's going to grip the leads better. Okay. It's looking pretty good. Now I'll crop those and then I'll flood a bit more solder on. That should actually come across the cropped lead. Hopefully the lead won't pop right in when I do this. Pretty good. These large solder joints tend to hold their heat for a while, so you have to be careful not to be too premature. And that is the lamp finished, and I'll just go and get a, well obviously I'm going to have to glue it into the base, but I'll go and stick it into get a lamp holder to try it. So I'll put it into this. Keep in mind it has to be glued in yet. And I shall plug that in. Et voila! A filament lamp with electronics in it. That looks pretty good. I think I'll just put the resin in that now and that should be it complete. Jump cut, and suddenly it's complete, it's glued together now. One thing I didn't think about with the gluing was that I put some glue into the base and then I pressed the test tube into it, and then of course that's creating positive pressure in the test tube and it wanted to pop out, so I'll have to think of a way around that next time. Maybe put a bit of sleeving or something in, just a U-shaped bit of sleeving to let the air flow out from inside the tube. But anyway, here it is. The lamp is complete. It looks quite nice, looks very three-dimensional, and I particularly like all the visible electronics inside. It looks quite stylish in its own right, and it also looks good lit. Nice 3D effect with reflections inside the tube itself as well. Power, according to the power meter, is 0.4 watts with a current of 4 milliamps. I tried this in a different power meter. I've got a couple at the moment, and one was just totally confused by it. It was coming up with a very erroneous 5 watt value and a unity power factor. I'm not 100% sure how it was getting that. I think it was being confused by the bridge rectifier and smoothing circuitry, but not 100% sure. But this more, I don't know, this tried and tested one is actually seems to be more accurate, and it says 0.4 watt, which is what I would really expect for something like this. So that's pretty good. Yep, it's a nice lamp. I shall now go and plug it in somewhere.